Hello, good afternoon, everyone. Today I'm going to spend a little bit of time to solve previous year questions. So all these questions are framed by national exams. Uh, some questions are yes, some questions are asked by CSIR national exam, and some of questions are in gate examinations. So last class we discussed about the some basic properties of elementary particles, such as conservation laws of elementary particles. So till now, calculate the almost all the conservation properties. Conservation of charge, we know how to calculate. Conservation of lepton number, conservation of baryon number, conservation of isospin, conservation of third component of isospin, the hypron number, conservation of hypron number, strangeness number. Okay, so all these properties are very important to check whether the reaction is conserved or not. Okay, so here I'm going to check the first reaction. Uh, I minus plus P tends to neta plus sigma. Okay, so here we want to find the charge barrier number, isospin number, and third component of isospin number. So for that we need to check quickly the isospin and third component. Okay. So what is isospin value? So we already discussed the isospin values. So isospin exists only hadrons. Hadrons means mesons and baryons. Baryons are two types of their spin. I mean -1/2 baryon, -3/2 baryons also there. So we need to consider all these things, and isospin also there. So isospin we can calculate by using this formula. It's the charge of particle minus average charge of the group of particles. Okay, then only we can get the third component of isospin and uh, uh, remaining conservation laws. So here I'm going to check this equation. First, charge. Charge is conserved or not. Okay. Just wait. Okay. First here I'm going to check charge. This is -1. Proton charge +1 tends to, this is 0. Okay. Plus charge of this one 0, plus charge of this one 0. So charge is conserved. Then I want to check this one baryon number. What is baryon number of this? Pi minus baryons, right? So elementary particles are divided into two types, right? Bosons and fermions. Okay, fermions are again divided into two types: light weighting particle leptons and baryons. Okay, in case hadrons, you need to add these k mesons. Okay, mesons also there here. Bosons category, you need to add both. Here the baryons, right? Baryon heavy particle. So this is 0. This is not baryon number. So 0 plus heavy particle baryon number is 1 minus. So this is the baryon. Okay. So general baryon number, there is no bar on this baryon number. Plus this one is 0 because this one is muon category, right? Plus this one is 1. So therefore here the 1 and here the 2. So there is no, this reaction is violating conservation of baryon number. Next, isospin. Isospin exists only hadrons. Okay. What are the hadrons? Some mesons and baryons. We know baryons. So how to remember this baryon? First, you need to one mind map regarding this elementary particle physics. So especially for calculating the baryon number. So from starting of this elementary particle physics, basic classifications are there. This one is a basic classification, fundamental classification. So in this classification, here the baryon, see some order is there, right? Order is here is how um, how I remember all these things in a national exams. Uh, this is first category, okay, and this one is second category. One is third. This one is the fourth. These are all the order, right? This order is there. This order, okay. So forgot this one. This order is there. These are all the minus one divided by two. Q, okay. Spin one divided minus one divided by two category. Okay. Spin. I mean, this one divided by two category variance. And remaining things are there. One is delta. See here. This order is there, right here. So you need to remember these things. Delta plus plus, delta plus, delta 0, delta minus, and these complex conjugate and remaining this one. These are the complex conjugate of this sigma and psi. Sigma particles, complex numbers, complex, complex, and this cosine, cosca, these particles, these complex numbers, cosine, complex numbers. So these are the variants under the category of minus 3 by 2 category. So this is how I remember in examinations. Don't forward anything. Yeah. So you just remember that easily you can understand without missing anything. Okay. Then you can solve the problems quickly. Then you can write here in examinations. Uh, then you can really calculate fast these reactions. So this isospin of this category pi minus, right? So pi minus is third component. Third component isospin is 1 plus proton and neutron. Two component group of two components is there like this Pn, and isospin I can calculate a group of particles into 2i plus 1, right? Here is a 2i plus 1, that is equal to 1 divided by 2. This is 1 divided by 2. Okay, this one. These are the three components. All the three components, this isospin value is 1. This is not isospin. Okay, isospin exists to only hadrons. Okay, so isospin of this single particles isospin is what is number of particles 1. Okay, you need to check this. Mesons also their hadrons, and this one. Okay, this is also meson category. This is a sigma, right? 2i plus 1. 1 minus 1 is 0. 2i. I equal to 0, which is y equal to 0. And this one are also 0. So this also violating uh, conservation of isospin. Then I'm going to check I3 component. So you need to careful by checking this I3 component minus 1 plus this is 1 by 2. This is 0 and this is 0 plus 0. So this is violating isospin. Next, second example. So these are all in previous exam questions. P plus P tends to K plus and sigma plus. So we need to check here the charge variant number isospin. Okay, first here I'm going to checking charge 1 plus 1 tends to 1 plus 1. So it follow conservation of charge, conservation of baryon number. So proton is baryon, right? Heavy particle 1 plus 1 and K plus sigma means. Where what is K plus? Where is the K? There is K mesons, right? No, it is not a baryon number. So this baryon number is 0. Okay, this is baryon number. This is baryon, original baryon, right? That's all. So therefore it is violating the conservation of baryon. Next, isospin. Isospin, you try to remember the multiplication formula of m is equal to 2a plus 1. Isospin exists only hadrons. So you need to check this hadrons are not hadrons, right? Hadrons isospin is there. Isospin group of two particle 1 divided by 2. Here also 1 divided by 2 tends to k plus, k plus and k minus. Like this there, k plus and k naught is there one thing, and k naught minus, k minus also there. Okay, so these are also 1 divided by 2 particles. Next, plus sigma. Sigma is sigma plus sigma 0. Three groups are there here. The sigma plus sigma 0, sigma is. So three groups. So charge 1, 0 minus 1 divided by 3. So therefore it is charge is almost 1. Okay. So this is also violating conservation of isospin. Next, third component I'm going to checking. Third component, I3 component. So I3 component, this one is plus 1 by 2, plus 1 by 2. We know right how to check third component. This is also plus 1 by 2. This is also violating the conservation of third component. So like that, we need to check the all the properties. Okay. And next, I'm going to check one important one. I plus P tends to sigma plus sigma plus is there. Sorry, this is K plus, not sigma. So we need to check charge, first conservation of charge. This is 1, this is plus 1, tends to, this is 1, plus 1. Conservation of baryon number. Pi is baryon or not? Pi is mesons, right? So mesons not baryons. This is baryon number 1. This is original baryon. Okay. Sigma. K is here, right, 0, right. This one. K is mesons, right? This 0. So this is also conserved. Next, isospin. These are three third component. This is 1. This is plus 1 divided by 2. This is also 1. This is also 1 divided by 2. This is also follow the conservation of isospin. Here I'm going to check third component, conservation law. So this is 1 plus, this is 1 divided by 2. This is also plus 1. This is also plus 1 divided by 2. So this equation is correct. Okay. Like that, you need to check for number 1. Pi minus plus P. We need to check this reaction. Second thing, P plus P sigma plus and this cosine. Okay. And one simple equation is there. You try to check these things. Okay. For practicing, these are the previous questions. Okay. Next, I'm going to discuss the very important information, that is how to identify the missing particle. How to identify the missing particle.